You know what I'm talking about. That outlet in your bathroom or by the kitchen sink, the one with those two little buttons in the middle. Test and reset. We see them every single day, right? But what they actually do and how they keep us safe, well, that's a whole other story. It's this brilliant piece of engineering that most of us just, take for granted. So let's finally figure this thing out.
Right, let's demystify this little household guardian. The whole puzzle really starts with a super simple question. One I bet you've even wondered about yourself while plugging in your phone charger next to a running faucet. And this is a fantastic question that someone actually posted online for a bunch of electricians. I mean, think about it. Your phone charger, it doesn't even have that third round ground prong. So how in the world can the outlet know if something's gone wrong? It really does seem like a paradox, doesn't it? The one thing we all associate with electrical safety, that ground pin, it's not even in play with so many of our everyday gadgets. So is the protection just for show? Nope, not at all. The secret is hiding in a totally different principle. Okay, this is the good part. This is where we get that aha moment. Because the way a GFCI actually works is so clever, but it's also widely misunderstood. And to solve this mystery of the missing prong, you kind of have to forget everything you thought you knew about how these things work. And you know what? This user from Reddit just sums it up perfectly. So many of us, myself included, figured the GFCI was somehow watching that ground wire, just waiting for a stray current to show up. But as this person found out, the real method is way, way cooler. So here it is, the key takeaway. Forget the ground wire for a minute. A GFCI is like a tiny, obsessive accountant for electricity. It's not looking at the ground wire at all. Instead, it is constantly monitoring the two wires that are always being used, the hot and the neutral, and its only job is to make sure there's a perfect one-to-one balance between them. Think of it like a perfectly sealed water pipe. All the electricity that flows out on that hot wire to power up your hairdryer has to come back on the neutral wire. The GFCI is sitting there, constantly comparing the flow in versus the flow out. The instant, and I mean the instant, it detects even a tiny mismatch, as little as 4 to 6 milliamps, it assumes that electricity has leaked out and found another path to ground. And that other path? It could be the water in the sink, or it could be you. That 4 to 6 milliamp number isn't random, by the way. That is the exact threshold where an electric shock starts to get really dangerous. And in a fraction of a second, boom, the GFCI cuts the power. And this is why the name makes so much sense once you get it. It's a ground fault circuit interrupter. It's not a ground wire interrupter. It senses a fault, electricity going to ground through a path it shouldn't, and it interrupts the whole circuit. See? Once you know the trick, the name tells you the whole story.
So this incredible life-saving tech didn't just pop out of nowhere. It was actually born from some really meticulous and honestly kind of dangerous research by one professor who was determined to figure out exactly what electricity does to the human body.
This is Professor Charles Dalzell. His work back in the mid-20th century was absolutely groundbreaking. He ran experiments to figure out the precise levels of current that could paralyze a person's muscles or, stop their heart. It was his research that gave us that critical safety number we just talked about, that tiny 4 to 6 milliamp range. That science is literally what's powering the little guardian in your wall today.
Now, Dalziel's invention wasn't adopted everywhere all at once. Its rollout has been this slow, deliberate process playing out over the last 50 years, all driven by the National Electrical Code. It's like they've been slowly expanding this shield of protection as we learn more about where the real electrical dangers are in our homes.
And this timeline really tells that story. The National Electrical Code, or NEC, started back in 1971 by putting GFCIs in the most obvious danger zones, outside and on construction sites. But from there, you can literally see the logic unfolding. The code just followed the water through our homes, first to the bathrooms, then to garages where you might be using power tools on a wet concrete floor, and then, of course, to kitchen countertops.
And here's the thing, that process hasn't stopped. The electrical code isn't some ancient text that's set in stone. No, it's a living document. It's constantly evolving based on new tech, new data, and sometimes based on tragic experiences. For example, the 2020 update brought a couple of really big changes. First, they simplified the basement rule. It used to be just unfinished basements, but now it's simple. If it's a basement outlet, it needs GFCI protection, period. But the second change, that one's arguably even bigger. For the first time, the protection was expanded beyond our standard everyday 125-volt outlets. And that is a huge deal.
For the very first time, the code is saying we need the same kind of protection on bigger 250-volt appliances. We're talking about things like your electric clothes dryer or your oven. The logic is exactly the same. If these powerful appliances are in a spot where there's a risk, they need that same life-saving protection. And the reason for this specific change? Well, it's incredibly sobering.
This rule wasn't changed because of some theoretical risk analysis. It was a direct response to a tragedy, driven by that number 3. 3 children died from electrocution because of improperly wired dryers. It is just a heartbreaking reminder that these codes, they are often written to prevent history from repeating itself. Every update is a lesson, often learned in the hardest way possible. So the next time you see that little outlet with the 2 buttons, you'll know the incredible story that's packed inside it. It's not just a piece of plastic in the wall. It's a vigilant guardian constantly doing that balancing act to keep you and your family safe. And it really reminds you that safety isn't a destination. It's this ongoing journey of learning and adapting, which kind of makes you wonder, what risks are we overlooking right now that will be protected by the standards of tomorrow?